Hello, welcome to this tutorial on mechanics. We'll be looking at motion of connected particles. We have our problems here. Two particles whose masses are 18 kilograms and 15 kilograms are attached to the ends of a light inextensible string. The string passes over a light frictionless pulley and the masses hang freely. The system is released from rest when 8 kilogram mass is 28 meters above the floor. Find A. The tension in the string. B. The time taken by the 18 kilogram mass to reach the floor. We are to take the acceleration due to gravity to be 10 meter per second squared. In our solution, we are going to represent the information in a diagram. We have the pulley here and the 18 kilogram mass is here, and then the weight of the 18 kilogram mass is the mass multiplied by acceleration due to gravity, 18 g Newton, and then the second mass is attached here. This is 15 g, which is the mass multiplied by the acceleration due to gravity. Then we now look at the tension as the act upward. The tension are the same for the two masses. Why are they the same? Because the string passes over a light frictionless pulley or a smooth pulley. So we have the tension to be the same throughout because it is passing through a light frictionless, that is, it is smooth. The movement of the string is smooth, no obstruction. That is why the tension are the same for the two masses. Then we now talk of the acceleration. For the acceleration of 18 kilogram mass, if the system is released from rest, it goes down, so it accelerates downward. And the same way, if the system is released from rest, the 15 kilogram mass goes upward, so it accelerates upward. The acceleration are the same throughout. Why are they the same? Because the two masses are passing through light inextensible string. The string does not stretch out. So as it means it is stretching out, then the acceleration will be distorted at one point because the string is inextensible. Therefore, the acceleration are the same for the two masses. So from here now, we can go ahead to look at the A part of the problem. For the A part, we start from the 18 kilogram mass. The net force for the 18 kilogram mass is going to be, since the object is moving downward, it's going to be 18 g minus the tension. And by Newton's second law of motion, we are going to have 18 g minus t to be equal to the mass of the object multiplied by the acceleration with which it goes down. So that is going to be equal to 18a. And we are going to have two unknowns here. We have the tension and the acceleration. So we are going to name this equation 1. Then we get the equation 2 from the second mass. So that for the 15 kilogram mass, the net force in this case is going to be the tension. Since the mass will be going up, it is going to be the tension minus 15g. And then by Newton's law again, we are going to have T minus 15g to equal to 15a, which is the mass of the object multiplied by the acceleration with which it goes up. So we now call this equation 2. We are going to solve equation 1 and 2 simultaneously. So by adding equation 1 and equation 2, we have 18g minus 15g giving us 3g, then minus t plus t gives 0, then 18a plus 15a will give us 33a, so that a will be 3g over 33 after dividing both sides by 33 to get our a, the subject of the formula. Since we are to use g equal to 10 meter per second squared, we are going to substitute here so that our a will be 30 over 33. In the simplest form, we have acceleration to be 10 over 11 if we are leaving our answer in fraction. And the unit there is meter per second squared. And that is the acceleration. We can then go ahead to find our tension. So from equation 2, we have our equation 2 here. We can make the t to be the subject of the formula, which is 15a, and our a is 10 over 11. So we have 15 times 10 over 11. Then taking this to the right hand side and applying our g to be equal to 10, we are going to have it as plus 150. Imputing this in our calculator, we have the tension to be 163.6 newtons as the tension in the string. And that's the end of solution to A part of the problem. The B part, we have to find the time taken by the 18 kilogram mass to reach the floor. Remember, the 18 kilogram mass is 28 meters above the floor, which means it is going to cover a distance of 28 meters for it to reach the floor. We then take that one as S equal to 28 meters, that is the distance. And since it is going to be released from rest, the initial velocity is going to be 0. And we already have our acceleration here to be 10 over 15 meter per second squared. And we are looking for time. So using one of the equations of motion, we use S is equal to ut plus half at squared. Our S is 28, and since u is 0, so we are going to have it equal to 0 plus half multiplied by our acceleration 10 over 11, then t squared. If we make t the subject of the relation, we are going to have it as square root of 28 times 2 times 11, then divide by 10. Imputing this in our calculator, we have the time to be 7.9 seconds, giving us the time taken by the 18 kilogram mass to reach the floor from a height of 28 meters. And that's the end of solution to this problem, and this is where we are ending this tutorial. Thank you for watching. I hope you enjoyed it. Please like and share this video. Until we come your way again, goodbye.